see a review of modern JavaScript. We will see features such as let and const, arrow functions, template strings. We will also see the ternary operator, improvements to the literal notation of objects, the structuring and the spread operator. We will also see classes, the map function, promises, async await, and modules. So, let's start by preparing the environment for this module. In this video, we are going to prepare our computer to work with the examples of this module. We are going to create two files, which are going to be a JavaScript file and an HTML file. So, let me start by creating the JavaScript file, new text document, and I'll say examples.js, enter. And also let me create that HTML file, so index.html, enter. Now I want to open this folder in Visual Studio Code, so I will shift right click here, open PowerShell window here to have this terminal here, and I will say code.enter, and that will open the current folder in Visual Studio Code. So let me make a simple test here. I will go to the examples.js file and I will simply say console log hello world, and I want to run this code. So I will go to a terminal, new terminal, and then I will say node examples.js, enter. And as you can see, we have hello world here, which means that we were able to run this file. Now I want to do something similar for index.html, so let me go there, let me close this, and let me start coding. I will make a simple HTML document, HTML here, head, body, and here I will say span hello world. Now how do I run this? We can use an extension so that we can just right click here and run it. So let's go to the extensions tab here, and I'm looking for an extension called live server. You can click on here and you can install this. I already have it installed, so I am good to go. After installing it, you should be able to come back here, right click here, and then open with live server. And this will mount the application into a server. In our case, it is localhost. We have here the index.html, and here we have the hello world text. With this, we are good to go to start working on the examples of this module. In this video, we are going to talk about let and const. But before that, we are going to talk about var. If you have used JavaScript in the past, you know that we can use var to declare variables. For example, I can say var first name equal to Felipe, and then I can use that variable. What I'm doing here is that I am using var to indicate that I will declare a variable called first name and its value is Felipe. Then I can say, for example, console log first name, and then I am using that variable here. For example, I can go to terminal, new terminal, and I can say node and the name of the file, let tap enter, and here we have Felipe, which is great. Now there is something that may be surprising for some people, and it is that if I delete var from here, the code will still work. Let's see that. Let me save, and now let's come back here and I will repeat the same command, enter, and as you can see, we still have Felipe here. Again, this may be surprising for people that have worked in the past with other languages, other compiled languages like C# or Java, where these kind of things would not compile. But that is not the case with the use of var in JavaScript, though we can circumvent this by using strict. If we say use strict, enter, then if I come back here and try to do the same thing, you are going to see that now we get an exception that first name is not defined. So we can use strict, or strict mode in order to avoid that weird thing with var. But not only that, there is another weird thing that we're going to see. Let me delete this and let me say for var x equal to 1, x less than or equal to 10, x plus plus, and I will just have an empty body here, and then console log x. What will this print? In other languages, this shouldn't even compile, but in JavaScript, this will run just fine. So let me come here, note let and const, enter, and as you can see, the value of x is 11. So the variable is retaining the final value that it obtained in this for loop, and then we can access that variable here from some place that should be out of the scope of the x variable. Because of things like this, let was introduced. With let, we have a more normal behavior for variables. The problem with var is that because of a process called hoisting, var declarations are processed before any code is executed. And with hoisting, then this variable gets created at the enclosing context, which means that this is like having this and this. This is more understandable, and this is actually what's basically going on because of hoisting. So how can we avoid hoisting? Well, by using let. Let me put this back on, and now let me say let, and that's it. With this, we're good to go. If I come back here and I say node, enter, you are going to see that we have an error, which is expected. The error is x is not defined. X is not defined because let does not use hoisting. The scope of a variable declared with let is the same block where it was declared. And how can we use let? Well, actually in the same way that we use var. I can say let name, actually first name equal to Felipe, and I can just use it. I can say console log first name, save, and I'll come back here, node let and const, enter, and we have Felipe here. And I can declare as many variables as I want, like last name, this should be last name, equal to Gavilan. And I can also edit those variables. I can say last name equal to Marrero, and that will be great also. I'm not limited to using strings, I can use numbers, so like let age equal to 999. I can also have dates like birth date equal to new date, and that is also fine. And of course I can define objects like person equal to first name equal to, let's say Eduardo, last name equal to Williams, and so on. And also I can define a variable that will have a function as its value. So let me say here let duplicate equal to function value return value times 2, and that is also fine. Now besides let, we can use const. With const we can define constants. So with a variable we can have a value that will be variable, which means that it can be changed, like this last name that I have here, which has its first value as Gavilan and then it is edited to Marrero. But if I wanted to have this unchangeable, I can use const. For example, if I say here instead of this let, I will say const. Now if I try to run my code one more time, I'll get an exception, which is that assignment to constant variable. This means that we have a constant here and we are trying to reassign it. This operation here is an assignment operation which can't be done once the constant is initialized. We initialize the constant here, now we cannot reassign it here. That is an illegal operation, and that is why we're getting this error. So let me comment this out here so that we don't have this error anymore. Now it is really important to understand that what we can't do with const is to reassign the variable, but we can edit its value. For example, let's come down here and let me say something like const person2 equal to first name equal to Scott, last name equal to Brown, and that is fine. And now let me say that I want to change the first name of person2. Let me say person2 dot first name equal to Alex. And that is not an illegal operation. I can, for example, console log person2, I can save, and I can come back here and I can say node let, enter, and as you can see we have first name Alex and last name Brown. Why don't we have an error here? Because we are not reassigning person2. We are not reassigning the variable. What we are doing is that we are changing a property of the object that the variable points to, which is different. What I can't do this, person2 equal to, and yada yada yada. I cannot reassign the variable. Can't do this. And if we try to run the code one more time, we're going to get an exception again. And as you can see, it is pointing to person2 equal, which is this, because we cannot reassign a constant. So there you have it. We have let, which behaves like normal variables from other languages like C# and Java. Let allows us to have variables whose its scope is defined by the block in which it was declared, and also we have constants which, as their name implies, cannot be reassigned once they have been declared. In this video, we are going to talk about arrow functions and this. Let's start with an introduction to arrow functions. In the previous video, we had a function like this. We had let duplicate equal to function value return value times 2. This is what we are going to call in this video a traditional function or just normal function. In a traditional function, we have the word function, its parameters, a body enclosed by these curly brackets, and then the body of the function. This is all great, but we can use another kind of functions, arrow functions. With an arrow function, we will be able to abbreviate some of the ceremony that needs to be done in order to declare a function, and also we are going to have a different meaning for the this keyword. Let's start by abbreviating this function. Let me say here let duplicate arrow. This is the arrow version of this function. And I will say here first the parameters of this function, which is going to be value, and then I am going to use equal to and greater than, which is like an arrow, which is why these functions are called arrow functions. And then here I will say value times 2. And that's it. These two pieces of code, these two functions, are completely equivalent in the sense that they do exactly the same. They are different because of the this keyword that we're going to cover in a few minutes, but other than that, they do exactly the same. And not only that, I can actually abbreviate this more because since I only have one parameter, I can omit this parenthesis here, and therefore this is the final result. We have a variable called duplicate arrow, which has a function stored in it, and this function takes one parameter, which is name is value, and then what this function does is to take that value, multiply by 2 and return that. How do we know that we're making a return? Because since we are omitting the curly brackets here, there is an implicit return. So what we're doing then is that we're duplicating the value that we're passing to the function. We can see that. We can say console log duplicate arrow, and I will pass a 3, and then I will open a terminal, new terminal, and I will say node arrow functions, enter, and as you can see we have a 6 here, which means that indeed we are duplicating this value. Now I am not required to do it like this. I can put the curly brackets if I want. For example, I can say let duplicate arrow 2 equal to value arrow, and I can say here curly brackets return value times 2, and this is more similar. This arrow function is more similar to what we had here, because since we are not omitting the curly brackets, then we must be explicit about the return statement. Now arrow functions, just like traditional functions, cannot return a value. For example, I can say let print something equal to, and let's say that this function doesn't have any parameters, then I need to say empty parentheses arrow and then console log, I'll just say something. And this is fine. This is another arrow function, but another case in which we have to define parentheses is when we have more than one parameter. For example, let's say that we have let addition equal to, and we want to sum two values, so value 1, value 2, arrow value 1 plus value 2. And as you can see, because we are defining more than one parameter for the function, then we are obligated to use parentheses also here. And of course, our functions doesn't have to be one-liners. I can say let complex function equal to whatever parameters. What I want to say is that we can have line 1, line 2, and so on. So as you can see, we can have simple arrow functions like this one or complex arrow functions like this one. Now let's talk about this. An important difference between normal functions or traditional functions and arrow functions is the this keyword, and I'm referring to this. I can have a this statement here and also a this statement in an arrow function, and they are different. The difference is that in, and let me close this so we have more space. The difference is that in a traditional function, the value of this is the value of the object that made the invocation of the function. That is, this varies depending on how we execute the function, whereas in an arrow function, that this value does not depend on who called the function, but on the place in which the function was defined, that is, the original environment. Let's see an example of this, just to make this more clear. Let me comment this out and also comment this out so that this code at least will compile. Now I will also comment this out, and here I am going to define an object. I will say const object equal to, and I will say traditional function equal to function console log traditional function, and I will pass that this. The idea is that with this we are going to print in the console the value of this, and I will do the same for an arrow function. I will say here an arrow function, and I will say console log arrow function this. And not only that, I want to define another property in my object, something simple like last name equal to Gavilan, and that should be fine. Now let's see what's the value of this. Let me come down here and say console log this environment. I want to get the value of this when we are here outside of this object, but now I want to say object dot traditional function and also object arrow function, and let's see what we get in the console. Let me come down here and I will say node arrow functions, and as you can see we have the following. Here we have that this in the environment, that the disk that corresponds to this line of code is just an empty object, which makes sense because we are in a JavaScript file which is not running in a particular interesting environment, and you can see that the arrow function has the same value. Why is that? This is because that this in this arrow function corresponds to where this function was defined, and the environment in which this function was defined is in this JavaScript file environment, which is why we have this environment equal to an empty object and arrow function, which is this value, also equal to an empty object. And in spite of that, we can see that here we have traditional function, which corresponds to this line of code. Here we have traditional function and then the same object that we define here. Why is that? Because as I told you before, that this keyword in a traditional function depends on how the function was called. And how was this traditional function called? Well, through this object that we have here, and that is why the value of this variable that we have here is equal to this object, because I get to call this function through this object right here. And you can even see this if you hover over this here. You can see that the value of this is this same object, and also the value of this is type of global disk, which is the same disk that we have here. Another example that I want to do is to come here to the index.html file and repeat that same experiment. Here in the body, I want to say a script, and now I want to come here and I want to copy and paste this, copy and paste this here, Shift Alt F to order everything. Let me minimize this to have more space, and let me move arrow function to be the second invocation so that it's close to the global one. So let me save, right click, and let me click open with live server, and here we have our page. Let me press F12, and here we have this environment, which is the window object, which is normal in a browser environment, and also arrow function, it's this value, is the value of the environment in which the function was defined. And where was our function defined? Well, it was defined here. It was defined here. And what is the environment of this place? The window object. And also, if we come back here and we go to traditional function, you are going to see that its value, the value of the disk, is also the object that we declared, the object that has arrow function, last name, and traditional function as its properties, which is this object that we have here. So as you can see, traditional function has this value that depends on how the function was called, and the disk of the arrow function has its value depending on where the function was defined. In this video, we are going to talk about template strings. The idea of template strings is to make it easier to work with strings in JavaScript. If you have worked with JavaScript in the past, you know that you can do the following: const my name equal to Felipe Gavilan here, and I just declare a simple string. I can also do const country equal to, and let me use actually double quotes, Dominican Republic. I am showing you here that you can declare strings by using single quotes or double quotes, and there is no difference between them. And because of this, they also have the same limitations. For example, if I come here and I say const greeting equal to hello, and I want to insert my name here, so for that I have to use this operator here and say my name plus the rest of the message. I'll say how are you, and this is fine, but there are better ways of doing this. For example, maybe I want to use something called a string interpolation, which allows me to insert values into strings in a simple manner. Let's do that. I will say here const greeting2 equal to, and here I will not use single quotes, I will use backtick. Look at the difference between this symbol that I have here and this other symbol that I have here. They are not the same. It is really easy to confuse them, but they are not the same. These are single quotes and these are backticks. They are called backticks. So here what I will do is that I will repeat the same message. I will say hello, comma, but here I will say $, curly brackets, my name, comma, how are you? And they are exactly the same string. They have the same value, but this one I find is easier to read because you don't have this plus operator here. What I'm doing here is that I am saying concatenate this string with this variable that I have here and then with the rest of this string. And that's actually it. By using backticks, I can use a string interpolation. A string interpolation refers to the operation of inserting a value inside of a string, like this one. But not only that, backticks also offer me the possibility of having a string divided into multiple lines. For example, I will say const message equal to, and I will use backtick one more time, and I will say hello, my name, and then I will press enter here, and as you can see, I will be able to say something like this is a message for you. And also something that I want to do is that I want to put a function here. I'll say add equal to a plus b. This is an arrow function which adds two numbers, and I want to use that arrow function here inside of my string. I can say the sum of 2 and 2 is, and here I can say add, and then I can pass 2 and 2, and what this will do is that it will print here the result of this operation, whatever this method returns. And after that I will just say bye bye, and that's it. Let me put this here and semicolon here. I can say console.log and I will print the message, and you will see that we have here a string divided into multiple lines. I will open the terminal, terminal, new terminal, and I will say node template tab, because this file is called template strings, and I'll press enter, and as you can see we have hello Felipe Gavilan, this is a message for you, the sum of 2 and 2 is 4, bye bye. This is really important because in this way we can write strings that are easy to understand, easier to reason about, and easier to update. This is something that we're going to use in the future, so it is definitely important that you know the difference between backtick, which allows you to have strings in multiple lines and also allows you to use a string interpolation, and single quotes, which are the classic way of working with strings in JavaScript, which are really limited. The same goes for double quotes, which we have here. Let's consider the following scenario. We have this age variable here and this message variable here. We are saying that if age is greater than or equal to 18, the value of message is going to be you shall pass, else message is going to be you shall not pass, and then we're going to console log that. That is fine in general, and that works. I can come here to terminal, new terminal, and then I can say node ternary tab, enter, and then it says you shall pass because age is equal to 21, and if we change it to 17 and we run this one more time, we're going to see that we have you shall not pass. Again, this is fine, but maybe you don't want this. Maybe you want to have this in a single line, and you can do that by using the ternary operator. With the ternary operator, we can abbreviate this operation in one line. Let me delete this, and let me also delete this, and I will say let message equal to, and I will open a parenthesis here, and I will say age greater than or equal to 18, and then I will say question mark here, which means that this is going to be either true or false. If this is true, then we want to assign this value that we're going to have here into this variable. This value is going to be you shall pass. Otherwise, we're going to evaluate this value that we have here, which will say you shall not pass. And this is exactly equivalent to what we have before. This is like saying if age is greater than or equal to 18, then the message that we're going to evaluate is you shall pass, so message is going to be equal to you shall pass. Otherwise, if this is not true, if this is false, then we're going to evaluate whatever we have here, which is you shall not pass, and therefore the value of message is going to be you shall not pass if this is false, which is the case right now because age is equal to 17. Let's do a test. Let's come here and I will repeat this execution and I will press enter, and as you can see we have you shall not pass because we console log message. Now let me change this to 18 for example, and I will save and I'll come back here and I will run my JavaScript file one more time and I will press enter, and we have here you shall pass, which means that indeed with the ternary operator we can abbreviate simple if statements in a single line like this. We already know that we can create variables like this, and that is cool, but we can also create objects. With objects, we are going to have several values tied together. For example, I can say let person equal to, and in order to declare an object in JavaScript, we must use curly braces. And in here, I can declare properties. Properties are individual values of an object. An object can have many properties. For example, I can say here country colon here and say something like Dominican Republic, and that is one property of the person object. I can also say something like last name equal to Gavilan, and then our object has two properties. We're not limited to using strings as properties. I can use numbers like age equal to 999 or date equal to new date. As you can see, we can have many properties of many types. What we're going to study in this video is enhanced object literals, which means that we're not limited to just using this kind of operation, but we can actually do more. For example, as you can see, we have last name here and last name here. And I am basically repeating this same value here. But maybe you don't want that. Maybe you just want to have this property, the value of this property, as the value of this variable. For that, you can actually delete the value of this property, and that's actually it. Now, last name has the value of this variable that we have here. We can do the same for age. Now, the value of person age is 999 because this is the value that we have here. Let me show you that. Let me console log that. I can say console log person.age, and now I will go to the terminal, new terminal, and I will say node enhance tab enter, and as you can see we have 999 here because the value of this age is the value that we have here. But that is not everything. We're not limited to using simple values like strings and numbers and dates. We can also use functions. For example, I can say here normal function, and here I can declare a function as a property of this person object. Then I can say something like person normal function, and I can run that function by using the person object. I can also use an arrow function. I can say arrow function equal to, and here I can define my arrow function. Just like my normal function, I can come here and say person.arrow function, and I can execute my arrow function. Something cool that we can do is to have dynamic properties. Here you can see that I am saying that country is equal to Dominican Republic. That is fine, but what if we want to have this dynamically? What if we want to have a variable here? We can do that. Let's say here, let property name equal to country, and then let property value equal to, I'll say Mexico this time. And now instead of having country here, I will delete this, I will delete all of this, and I will say a square bracket property name equal to property value, comma. And that's actually it. Now person has the country property because this will get evaluated to country and property value will get evaluated to Mexico. Let's see that. Let's come down here and let me say console log person. I will console log the entire person object. I will save and I'll come back here. Node enhance object literals. I'll press enter. And now as you can see we have country Mexico, which means that indeed this is working. Now how can I access this property that we have here? Well, let's try the following. Let me say here country, and now this will work. Let me press enter. This will work, Mexico, but this is not good because we don't know if in runtime we're going to actually have a country property in our person object. Another way of doing this is to use a square bracket here. In this way I can pass property name and this will get evaluated, and then we're going to get here the value Mexico. Let's do that. Let me come here and let me run this one more time, and now as you can see again we have Mexico, but this time we are using this notation in which we can pass as a parameter the property of the object that we want to read. This is really useful for when you want to get the value of an object and that property, that value, is dynamic. This can be the parameter of a function. Let's see an example of that. Let's say return value from person equal to prop, and I will say here person prop, and as you can see ahead of time we don't know which property we're going to try to read from the person object, but here I can say for example console log return value from person, and I can pass whatever property we have here. For example, I can pass last name. Let me come here and say last name, and then I will save and I will run this one more time, and as you can see we have here Marrero because we have Marrero here.